One of the most dangerous times for an astronaut is re-entry to Earth's atmosphere. Most recently, we've watched the Shuttle return home and re-enter our atmosphere.
Anytime you have a spacecraft that goes into outer space, one of the major design challenges that you have is how to protect the vehicle when it comes back out of space and re-enters the Earth's atmosphere.
Robbie Kearns manages NASA Langley Research Center's space operations.
So the material that was on the bottom of, say, the Apollo spacecraft actually burned off as the vehicle re-entered the Earth's atmosphere.
This process is known as ablation.
And there was enough on it to protect it throughout the peak heating times, which allowed it to protect the spacecraft until it splashed down in the ocean.
The Apollo spacecraft was designed to be used only once. Today's shuttles are designed to travel to space over and over again for as many as 100 missions. Re-entry is still an issue for the shuttle. The same extreme conditions of space still affect this craft.
So how did the NASA engineers solve the problem this time? They turned to a substance that exists in the most extreme conditions on Earth: sand.
The desert gets incredibly hot during the day, but at night it can get downright frigid. And the sand handles those changes with no problem at all. Those temperature variances are nothing when compared to the tough conditions astronauts face when traveling from the harsh cold of space to the hot friction of re-entering our atmosphere. When the shuttle's in space and passes through Earth's shadow, the temperatures can be as low as minus 157 degrees Celsius. That's minus 250 degrees Fahrenheit. And when the shuttle re-enters Earth's atmosphere, the friction can cause those temperatures to soar as high as 1,650 degrees Celsius. That's 3,000 degrees Fahrenheit.
When the orbiter re-enters, it re-enters at a very steep angle. As the flow comes up, it wants to come up and then go over. And that turbulence and that velocity of the air that moves over creates a tremendous heat zone.
Back to the sand. So, how does sand fit into this equation?
The tiles really are a unique piece of engineering. They're very lightweight, and what people really don't realize is that they're just sand. They're made of quartz sand, and it's bonded together in such a way that the sand is spaced apart within the structure, and it's very, very lightweight.
That's right. The tiles that cover the shuttle's surface and protect it from extreme temperatures are made mostly of sand. And just think about how many of these tiles are needed to cover the shuttle.
Now, there are about 32,000 different tiles on the orbiters. Each one is specifically designed and sized to fit a specific location.
It's like a giant puzzle. Each piece must fit precisely into the ones beside it. And with the irregular shape of the shuttle, that's no easy equation to figure out.